Hi everyone, I'm going to talk about JavaScript generators today and how to write simple asynchronous code and in a beautiful way. I'm working as a full stack developer at Theodo. So Theodo is an agency. We're doing web and mobile developments, and we're working for big corporates as well as young startup. And we try to help them implementing their solution with using Scrum and Lean. Here's my details also, so if you want to give me a shout on either of these social network, feel free. So what I will kind of talk today, I will talk about generators. So first we'll go into details like what is a generator, because maybe some of you don't really know exactly what a generator is. Then I will talk about one library called Co that you maybe have heard of, which helps you to write asynchronous code using generators. And then I'll talk about how Co is used in Koa. So for those who don't know, Koa is the Node framework like Express. So let's start. Generators. What is a generator? So you have several terms. You have to understand what it is. So the first one is generator function. Generator function looks a bit like that. It looks like a classic function, but with a star and a yield statement instead of a return. You can have several yields in the same. And so this is not a generator. This is just something that will define a generator. And to get a generator, it's also sometimes called generator object, you need to call that function. So when you call generator function, you get a generator object. And the generator object will expose a next method to go to the next step of the generator. And since it's exposing this next method, generator is also an iterator. You might have heard this word before. So iterator in JavaScript is any object that exposes a next method. So we have basic knowledge now of the terms to understand the rest. Very simple example. How would you count to 3 using generators? So here my generator function, really simple. I first yield 1, then 2, and I stop by returning 3. I instantiate my generator by calling the function count to 3, and then I call next 3 times. And when you yield, when you call the next function of the generator, you get back an object that contains 2 attributes. The first one is value, and its value is exactly what you yielded or returned. And the second one is done. Is the generator done? It's always equal to false if you are yielding, and it's equal to true when you are returning. And you can return only once in a generator. Now, let's see how you can pass an argument to the generator. So here I have an example of a counter. And if you can see, I'm doing a while true loop, so an infinite loop. It's probably one of the only places where you can do that safely. Generators are always posing, so you can easily, this just means that my generator will never end, but it doesn't really matter because if I don't call next function, it's okay. So here I define my should increments being the result of my yield, and then if I ask to increment, I will just increment the counter. And I'm calling the generator next several times. The first time I just start the generator, gets the 4, which is my initial value. And then if I call gen next of true, I'm setting should increments as true for the rest of the execution. Then it's looping again and again, and you can see if I say gen next of true, I'm actually incrementing the counter, and if I say false, I'm not. So it's an other really useful feature. When you use generator, you need to be careful of what we call closure. Here's generator. I'm doing actually a map over an array. And inside a map, I'm using a function, of course. And if I try to use yield, it's not going to work because yield is only defined inside the generator. And here in my map, I'm actually inside a function, so I can't use the generator. So this generator is actually broken. So it's something you need to be careful about. You can't really use functional programming in generator, or actually, at least you can't yield inside functional programming. And now maybe something that is quite useful because you maybe are wondering how can I use a generator. One common way of using it is to iterate through a generator. So since an iterator, you can call the next function. So here my generator is the second block. You can see the greeting generator. I'm just defining the name being the result of my yield. Yield is not such a weird object containing the first attribute being a function, the second one being arguments. And I yield twice. First one I will yield get name with no arguments. Second time I will yield console log with a string of arguments. And then if you look at my iterate generator function, so what happens is that I do again infinite loop, so we just run until generator is over. And what I do is I get back the done on value from the result of the yields by calling gen.next. And if I'm not done, I will just define my next parameter for my gen.next being equal to the result of the function call with the arguments. So doing that, I will actually, if you look at the greeting generator again, you will see that name will be the result of getName with no arguments, and the function return Bruno, very simple. And then next step, I will console log hello, my name is the value of name. So I will see hello, my name is Bruno. So this is maybe the simplest way of iterating for a generator by passing the result of the previous yield to the next step of the generator. So now we're going to look into Co. So Co is a library that is used to be able to write asynchronous code in a synchronous way. Because instead of yielding functions and calling them, what you do is you yield promises. So here I have two functions that return promises. I have getName and getScore. First one resolved to Bruno, and the second one resolved to 12. I have my generator. I will first define my name, the result of the yield of getName. Second one defines score, result of the getScore of the name. And then I will execute my generator by wrapping my generator in Co. It will give me a promise, and then when I do promise.then, I get the value, which will be the return value of my generator. And so maybe it looks quite nice. It's really easy to read and really easy to understand when you a new event to generators. But maybe there's some magic behind, and this is what we're gonna look into now. So we'll try to live code and recreate Co from scratch. So here we go. This is exactly the example I just showed you before. The same method returning promises, the same generator. So now if I run, I get Bruno 12, exactly what I expected. So now what's going to do is going to just remove Co, and we're going to define it together. So Co is a function. It takes a generator object, and it returns a promise, I think. So let's go like that. New promise. So define my promise, resolve, reject, and let's do some stuff with it. So how I want to proceed, I would like to start my generator to run, and for that I will just call run of gen.next. This is ready to start the execution. So now interesting part is what is the run function that I want to implement. Sorry, the run function. So the run function will take one argument, which will be the result of the yielded value from the next step of the generator. So it's an object containing value and done. And what do we do with that? So if it's done, it's the easiest one to start with. If it's done, it means I'm returning. Returning a value is probably the last value of my generator, so I just want to return it. It's my string at the end, so I want to return it. So we return just resolve value. Cool. Now what happens if it's not done? Then value is probably a promise, or one of the promise returned by getName or getScore. So what I want to do is I want to do value dot then, and then so we return that. And then I will go into one onFulfilled function. So what happens when everything goes well? OnFulfilled. Takes one argument, which is the result of my promise, and do something with it. And what I want to do is I want to call the next step of my generator with that. With the parameter being the result of the previous promise. So for that, I'm just going to call run again with gen.next of results. So here, if I don't do any mistake, when I run, I go through the first step. It will yield some value with the return value of my promise, and I will inject it in generator for the next step. So if I try, did I do any mistake? Apparently I did. Brackets around that, I suppose. I still get my Bruno 12, so it's something working, but I still have a problem. So I need to resolve that. No, actually, I resolve at the end. Okay. It's always the same. So now what happens if something maybe doesn't go well doing your promise? So let's say now I will change a bit my promise, and here I will just get an ID and return depending on the value of the ID. If ID equal 1, return promise resolve, else return promise dot read. This one will resolve this one unknown. And now my get score will take the name as a parameter and return different value depending on the name. So if name is Bruno, I return the same thing. Else I will reject, simple one, reject an error. So now if I run my generator, I need to instantiate my generator with an ID. So let's say now if I take something else than 1, so I take 2, I should have an exception. Okay, so I have reject not defined. Oh yes, of course. Yeah, promise dots, you're right. Cool. Error, rejection, error. So we get exactly what I rejected. So now we want maybe code to be able to handle that. So for that, we need to be able to handle something when a promise doesn't resolve. So then we have on failure. And what we want to do on failure is actually almost the same as when everything goes well. The only difference is that instead of calling next, we want to call the throw method of the generator, which is the way to tell the generator something went wrong. We have to raise an error. So I pass it back. And now if I want to handle that in my generator function, I can just do a try catch as classic synchronous programming. Oops. Catch. So then if I run it, I'm still rejected. Get score is rejected with error, and when you're in get score, you're in the yield, then you should go on failure. And on failure is supposed okay. Can be property then of undefined. Okay, that's probably why. Okay, I guess I'm lost in my live coding, so I get the easiest way to show you the solution. We're not that far from it. Not far from it. So in the same code we have seen the function with before. Here we have on the same way. The unfulfilled function we have almost the same, but the return gen next of the results. On error we return the throw. So I don't see where I did my mistake, but it's probably a typo somewhere. And then what happens next, the next step we want to handle maybe is that if the generator is failing itself, so if I use throw in the middle of my generator, you need to be able to try catch your run function. So you wrap your return run into a try catch and return whatever you want to explain to the user that actually his generator is failing, and he should probably check his code. So actually it's quite impressive. You see like we rewrote code in like 20-ish lines. And we almost have everything. The only thing missing compared to the real code, that right now I can only yield promises. The real code, you can yield other kind of objects like values or functions, these kind of things. But the only thing you have to do is complete this if here and do all the different cases, and then you can recode the real code. So if you want to have a look at the gist, you can go to my GitHub. There is the 20 line of code, and you can look at them to understand details how it works. Why would you use Co? Co is it's used almost everywhere. This is the NPM package screenshots, and there's like 3,800 dependencies. And you can see some, for example, like Koa here. So this is probably why we're going to go to the next part of my talk, which is Koa version 1. Why version 1? Because version 2 is now using async await, but version 1 is using generators. So as I said before, Koa is a Node framework, very close to Express. There's a stack of middlewares. The difference with Express is that each middleware is a generator. And this is an example of the hello world from the documentation. So you define, you want your app to use two middleware. The first one is a logger to log how long the request takes to go through. And the second one is to return hello world. And how it works is when you yield next, you actually go to the next generator. So the first line of code being executed is define a new date, then going to this body called hello world, and then coming back to checking how many milliseconds this has taken. And how Koa is working. So this is the next simplified version of Koa in 20 lines again. And maybe the important part here is a lot of details. Maybe it's not that difficult, but it takes maybe a little while to understand. But the important part is the callback. This is the callback of the HTTP node server. And what it takes request response as usual. It generates a context, the context that will be shared by all generators. The generators will actually only do one thing, is to modify the context. The context will contain all information about the response, the headers, everything you can imagine. And after that, it's just one big promise resolution. So you just wrap in Co one middleware. And then you just do .then. If everything went well, you just return the response with the body of the context. And if there is an error, you just console log the console error, what happens. And now maybe you're wondering what is this compose function. This compose function is actually taking one of each of the middleware in your stack and returning a super middleware containing all of them. And how they are run, if you look at this diagram, so you have the time in the y-axis. And first, you're starting for the middleware 1, is running instruction. As soon as you have a yield next is actually a promise. It's actually a co-promise. Next is the next middleware wrapped into co. So it will run the next generator as a promise. But the next generator is also yielding next, which is also a promise. So it will go to the third generator. It will be run. When the third generator is over, the promise is resolved. So you come back to the previous one. The same, so the end of the previous one is executed. The promise is resolved, and you come back to the first one, where you can finish the execution. This is how you create a stack of middleware using generators. So all of them are actually a simple promise that is generated using Co. And now, Koa is using async await in a new version. So async await is probably like the new way of writing asynchronous code in Node, in JavaScript in general. But for any reason you are stuck into an old version of Node because you have an old infrastructure or you can't update, you have dependencies, then generators are available since Node 4.8, whereas async await is only for version 7.6. So generators is quite an old feature on Node, and it actually allows you to do some very powerful stuff. And sometimes actually you need generators, you can't even use only async await. I think, for example, into Redux Saga for those who are front-end developers, you need to do something about what you are yielding. You can't do that with async await. Async await is just to wait the promise to be resolved. But for Co, it works really well. So for Koa also, so then you can just use async await instead. That was all for me today. And if you have any question, feel free to grab me afterwards around the beer. And all the two pieces of code I showed you today, they're available on GitHub. So if you want to have a look, if you always wondered how Koa or Co was working, feel free to check out. Thank you.